Physical design is how what you have designed should be physically stored in the secondary storage, which is usually your hard disk or what we call secondary storage. Okay, so there's a physical database design process that you need to go through. Now, basically, we need to design how to store the data under each column of a relation. Each column is also called a field. Okay, and then in one relation, right? A relation is actually a table with many rows, right? So for each row is actually a combination of many columns or many fields. So many fields in one row combined together to make a physical record, okay? And then each record is one row. So all the rows inside a table or relation combined together forms the physical file or the physical table, like customer table or student table, right? In previous lectures, we were doing logical design. In logical design, we took your ER diagram or your enhanced ER diagram. We use a case tool and transform it into relations or tables, okay? Now, at that point in time, it's still a design, a logical design. Yet nothing has been implemented physically on how to store it on the hard disk. So here in physical design, we need to convert what has been drawn in your ER diagram and enhanced ER diagram, and what has been produced by the ERD in the transformation into technical specification for storing and retrieving data. Now, this part is actually combined together with the logical design when you use a case tool. So when you use a case tool, usually besides drawing your ER diagram, you need to specify for every attribute what is the data type and how you're going to store it, the meaning of it, and so on. So in a way, you've already been doing physical design when you're drawing your ER diagram. So create a design for storing data that will provide adequate performance. Adequate performance means the time taken to retrieve data should not be too long, okay? And at the same time, ensure the database integrity. That means the data must be consistent. You know that in relational database architecture, we have many relations or many tables, and different relations or tables are connected to each other through some duplication of data. And the duplicated data column is usually the foreign key, and it points to a primary key in another table. So the foreign key is usually a column that is duplicated from the primary key of another relation, okay? So whenever you have duplicated data, you may have inconsistency of data. So here we want to ensure the database is consistent, and therefore the integrity of the data inside is up to date and consistent, okay? So no errors, no insertion, deletion, or modification errors. Data must be secure and data must be recoverable. In case anything happens like the hard disk crash, can you recover the database again from the backup? So usually the objective is a balance between two things. You want to have efficient storage space. That means you want to minimize duplication of data, but at the same time, maximize the use of storage space inside your hard disk, okay? Versus processing speed. How fast can you retrieve the data from the secondary storage of the hard disk into the RAM memory of your notebook or your PC or your server and so on, okay? So you want fast retrieval, and you also want efficient storage, use of storage in the hard disk. So this is a balance between 2 points, storage space, which is memory space, versus processing speed. And usually when you're trying to decide between these two, efficient processing tend to dominate. That means that we try to optimize efficient processing, because the storage space like hard disks are getting cheaper and cheaper nowadays, all right? So therefore, we try to optimize to have faster processing speed versus how much duplication of data you have, all right?